Hello and namaste everybody. Myself Deepak Rajbhat, who I'm regarding from physics student of CDP Central Department of Physics in Kirtipur. Today I'm going to present uh, and verification and interpretation of the truth table for different logic gated by virtually. Uh, this is my address uh, for for contact. You can contact me by this contact number, email address. In the first page, I write here different content table, aim of the experiment and their corresponding page number, abstract, apparatus required, introduction, literature review, theory, and methodology, similarly circuit diagram, likewise observation, advantage of virtual experiment, similarly limitation, precaution, result, conclusion, acknowledgement, reference, and at last appendix. Aim of the experiment: to verify and interpret the logic and truth table for OR gate using diode resistor logic, in short we say DRL, and NOT gate using transistor and NAND gate, and OR gates using transistor resistor transistor logic, in short we say that RTL in simulator 1, and we also verify the different basic gate. Abstract, we write here abstract, I write here abstract. We can see the abstract here. For conducting the virtual lab or physically, we need two different apparatus, which are as follow: switch, power supply, resistor, transistor, diode, connecting wire, lead wall, bridge wire for physically. But we need extra moreover than in virtually. We especially we need to do this practical art, cell phone, our laptop or desktop, as well as the well internet access. This is our apparatus required. Extra apparatus also may be required during this experiment, such as like our wire introduction. The general introduction of the logic gate are: these are the building block of the digital system. Logic gates are electronic circuit having one or more input and only one output, which gives the logic decision. On the basis of this input and output supply, logic gate are constructed into the different manner. Basically, the fundamental logic gate are AND gate, OR gate, NOR gate, and beside this, there are other different kinds of gate, which are NAND gate, NOR gate, XOR gate, XNOR gate. And here I also mention the literature review as well as the theory. Logic gate, the theory of logic gate are this is the basic building block of the digital system. In electronic device, logic gate are the electronic circuit having one or more than one input and only one output, and these are the electronic logic gate: AND gate, OR gate, NOR gate, NAND gate, NOR gate, XOR gate, XOR NOR gate. Today I mention only not AND gate to NOR gate. This is the logical symbol for AND gate. Among this, now I'm going to elaborate about the AND gate. AND gate is a one kind of the electronic circuit. It has two input A and B, means from there we can supply high or low input signal according to our needed, and it gives only one output. This is the logical symbol of AND gate, and this is the this is the truth table of AND gate. And the electronic circuit of this AND gate by using TRL or RTL, resistor transistor logic, is as shown in the given figure. Generally, the output of the AND gate is depend upon the low signal, means zero. So it is also known as the low sensitive. electronic gate, OR gate. And next our OR gate. The logical symbol of OR gate is this. It has also two input, maybe more than two if we construct in our desire. And generally the OR gate is constructed by this way. The Boolean algebra of the OR gate is a plus b. This plus represent the OR gate, and this is the truth table of OR gate. And there are so many theory about it. OR gate. This is our OR gate through the DRL. DRL means direct resistor logic. I mentioned here, and after that, NOT gate. The NOT gate is an electronic circuit that also produces an inverted version of the input as its output. Means if we supply low to the given logical gate, and it convert into high, which is also clarify from this truth table. This is the truth table for our NOT gate, and this is the logical symbol for NOT gate, and this is the electronic gate, means NOT gate through the transistor. By using transistor, we can construct our NOT gate. And likewise our NAND gate. And NAND gate is the noted of AND gate. Means it is the complement of our result of AND gate. The logical symbol of the AND gate is this, and truth table is this, and this is the figure which represent the AND gate through the RTL, resistor, transistor, logic. And likewise, next one is NOR gate. This is the NOT of OR gate, means it is the complement of output of OR gate, so it is known as NOR gate. This is the generally this is the logical symbol of NOR gate, and this is the truth table of NOR gate. This is the figure which represent the NOR gate through RTL logic. And next one is our methodology. Now I'm entering into the methodology. How can we verify virtually? These all are given here into the topics of our methodology. We have two simulator first and simulator second. Now I'm going to simulator first to verify, to do virtually these different kinds of logic gate and their truth table, their result, and their interpretation also. Simulator first. In simulator first, step first means the first step to do simulator is we should connect our battery, nearly 5 voltage battery, to the circuit, and we should press after that we should press input A and input B as our desire, as our instruction. And if the bulb does not glow, means if we supply low input to the corresponding given circuit, then it gives their output with the glow of bulb. If bulb does not glow and we think the supply input is low or maybe high, which depend upon the logic device. And in simulator 2, likewise in simulator 1, we also do the simulator 2 to do virtual lab. First we enter the Boolean input, means like circuit switch 1 is 1 means high, or 0 means low, and we enter the output also according to our logic gate. And after that we click on the check button, then we verify the given logic gate work by which formula. And this is the circuit diagram of AND gate in our virtual lab. Now I'm going to enter into the virtual lab. For performing this virtual lab with virtual device like this laptop or our cell phone, we should write this, we should type this browser address. After that, we enter into here, and this is the virtual lab web, and there are so many content we have given in theory, pre-test, procedure, and in procedure we know about how can we verify this OR gate, AND gate, and how can we do this practical. We here we have given step by step this all instruction. Now we enter into the next simulation. Now at first I'm going to verify our interpretation to the AND gate. So we enter into the AND gate. This is our simulator first, this is our simulator second. And first we connect the battery with the given circuit. We introduce the battery of the given circuit. For introduce it into the given circuit, we click on here, and now our circuit is complete, and I'm going to verify I'm going to do the experiment of AND gate. So we need to switch on, and after switch on, the electricity passes through this way, and we have given here two switch A and switch B. This switch A and switch B gives the instruction, means gives the decision to our transistor, and finally we get our result on the LED bulb. This is our LED bulb, this is our battery, this is our switch for generate the circuit, and this is switch A for given to the high, either low signal into the given circuit. Likewise, this switch B also has the same task to switch A. Now I'm going to on the switch A, and we find out there is low output signal. If we give the switch A its high signal, and we find here low signal, as well as I'm going to give the high signal from switch B, also we get the same result as previous. Now I'm going to give the high signal from the both circuit, and finally we find here high signal. This is the experimental verification of AND gate. Now I'm going to enter into the simulator 2 for AND gate. This is the logical symbol of AND gate, and here we gives the instruction, means high, either high or low signal onto this our AND gate, and finally we write here output also and check out. And if we give the correct instruction, or if we give the correct observation, or if we give the correct input to our logic gate, and we find here correct result, otherwise it gives us incorrect result. Now I'm going to, at first I'm going to give the low signal from switch A, and also low signal from switch B, and AND gate gives during low and low, it also gives low result. So now I'm going to check my result is right or wrong. Check, it gives correct result. Now similarly, like previous, now I'm introduce high signal from switch A, low signal from switch B, and finally we get low signal from output. So I'm going to check correct. Similarly, now I'm going to give low signal from switch A, high signal from switch B, and we also get low signal output. I'm going to check this is also correct. Now I'm going to giving high signal from switch A, high signal from switch B, and finally we get high signal from high signal output. I'm going to check. This is also correct. This is the virtual lab for doing the AND gate by uh, simulator 1 as well as the simulator 2. If we need the print, then we can also print from here by click on the print option. Similarly, now I'm going to do the next virtual lab onto the OR gate. Yes, now we enter into the OR gate into the virtual lab. This is our simulator first for OR gate. There are two diode and two switch, and there is LED bulb, and there is resistor. This is resistor, and this is our battery, which gives the source, which act as a source. At first, we click on here for connect onto the given circuit. Now the battery is completely connected into the given circuit. Now I'm going to do the virtual lab. At first, we supply the low signal from diode 1 and low signal from diode 2. During that condition, the bulb does not glow, which represent our gate. And between these two, switch A and switch B, if anyone is high, then if anyone signal is high, then bulb glow. Now I'm going to give the high signal from switch A. Now look here, bulb is glow. And again from high signal from diode 2, and this also glow. As well as OR gate gives the high output during both the bulb A and B is high. B are high. So I'm going to click on A on high, B on high, the bulb also glow. This verify our this this is the idea to know the given circuit is OR gate or other logic gate. Now I enter into the simulator 2 for conducting OR gate. Like as our previous AND gate, we also give the low signal from switch A as well as the low signal from switch B, and finally we get low signal onto the output. Okay, now I'm going to check. Yes, correct. Now high signal from switch A and low signal from switch B, and finally I get high because either any one input is high, then the output signal is also high for OR gate. So I'm going to check. Yeah, this also correct. Now I'm going to give the high signal from switch B and low signal from switch A, and we also get a high signal from their output. I'm going to check. Yes, this also correct. If we give the high signal from the switch A as well as from switch B, and finally we get high signal output, I'm going to check. Okay, this also correct. Likewise, this we should follow the instruction of for other gate, and we can do the virtual lab for other gate, NOT gate, AND gate, NOR gate, XOR gate, and XNOR gate. This is the virtual lab for doing the logical performance verification and their interpretation. Yes, for conducting the different virtual lab, we should know the web browser address, then we can easily perform this experiment. Now I'm going to enter the my PDF. We also right here draw here so many circuit diagram of the given experiment, and these are the experiment, these are the given diagram. Just like as our gate, we do this in virtual lab, and this is our NOT gate virtual lab. Now we do in virtual lab. This is our AND gate picture in virtual lab. This is our NOR gate, like as other. Now this is our observation. We do this observation into the virtual lab. From here 1 and 1, and our output result is also 1. Then we get a high result for AND gate. Similarly for OR gate, if we give here 1 1, and finally we get output result 1. This is also verification for OR gate. This is the observation for different gates. And now I'm going to present the advantage of this virtual experiment. During this pandemic situation, this virtual lab is one of the best way for conducting the so many experiment to the scientific passing students as well as other person researcher, like as other who concerned with these topics. Okay, it satisfy the scientific passion, and it save our time and effort to do the experiment. And similarly, it allows to record the result electronically with the help which help to interpret the data using the various software. And a student can conduct the same experiment multiple times, which is not generally possible in our physical lab. It will also help to the student to get familiarized with the modern tools and simulation techniques. It enables to display the accurate phenomena as well as to measure the different kinds of the to measure or to interpret the different kinds of the verification. Beside this advantage, there are so many limitations. These are here. I mentioned some of these are here. For the truth, for the virtual lab, students have a mostly necessary desktop or either laptop. It is too difficult to visualize the experiment during by using the cell phone mobile. We should also need to proper internet access, otherwise it is impossible, and student may not get the same confidence as like in our physical laboratory. Physically we get the high skill confidence, but in virtual lab practically skills may not be developed. For conducting this our experiment, this truth table verification and verification of truth table, we should follow this precaution minutely. Proper connection should be done, otherwise we may not get the desired result. Appropriate resistor and transistor should be used. Likewise, in our virtual lab, we should also follow the so many precautions like this: proper connection of the battery, as well as the proper our browser, proper software, proper our device, means well organized device, well device. This is the result of our AND gate. This is the theoretical truth table, and this is our virtual truth table, means observed truth table. And we have also I have also this theoretical truth table for OR gate, theoretical truth table for observed truth table for OR gate, as well as for other gate. And I also mentioned here conclusion. Conclusion is that to observe the truth table, we should use the we should use the simulator first and simulator second. By using the simulator first and second, the truth table for AND, OR, NAND, NOT, and NOR gate has been verified. The observed truth table is same as the theoretical truth table, or corresponding logic gate. I also write here acknowledgement, and I would like to, and I also write here different references from where we can obtain the knowledge as well as the idea about performing these different kinds of the logic gate verification or practical. And at last I also write here uh, appendix. In appendix I write here viva question and answer. There are so many possible viva question and answer. Among these I only mention 6 question answer. At last I want to say thank you so much for our HOD sir to gives us this golden opportunity and to uh, realize this our virtual experiment. I would like to express my sincere gratitude to our HOD CDB2 members for providing me this golden opportunity to perform the virtual lab experiment. I am fully indebted to all the teacher staff of department for their valuable guidance and support. And I am also grateful to my friends who support me during this entire work. Especially thank you to my friend Ashok Chaudhary as well as the mm, our other friends who gives me uh, who support me uh, during this all do perform this all or the collect this all virtual data data and at last but not at last I'm thankful to one and who and all who helped me directly or indirectly to complete this experiment. Without their continuous guidance and support, this virtual experiment would only my imagination. And at last, I want to say thank you to all mm, for watching this.